Scientists map hidden fault that could trigger Turkey's next major earthquake.
Turkey is situated in one of the most tectonically active regions on the planet, where plates such as the Eurasian, African, Arabian, and Anatolian constantly collide, generating a long history of devastating earthquakes. One of the most tragic was the Erzincan earthquake in 1939, which caused the death of more than 30,000 people. Since then, major seismic activity has been progressively shifting westward along the North Anatolian Fault, one of the world's most dangerous transform faults.
One of the most tragic was the Erzincan earthquake in 1939, which caused the death of more than 30,000 people. Since then, major seismic activity has been progressively shifting westward along the North Anatolian Fault, one of the world's most dangerous transform faults. Many experts believe that the next major earthquake will occur directly beneath the Sea of Marmara, a part of this fault that has remained silent for over 250 years. This long period without significant ruptures has allowed a huge amount of energy to accumulate, increasing the risk for one of the country's most populous areas, including the Istanbul metropolitan region. Until recently, the detailed structure of this underwater fault remained largely a mystery, what scientists call invisible. Despite decades of research, without a clear map of what happens in the depths, it was difficult to accurately predict where and how a new earthquake might begin.
Now, an international team led by Dr. Yasuo Ogawa, Professor Emeritus at the Tokyo Institute of Science in Japan, and with the participation of Dr. Tülay Kayakan of Boğaziçi University in Turkey, has managed to create the first complete three-dimensional model of the subsurface region beneath the Sea of Marmara. The work was published in the journal Geology and represents an important advance in understanding this threat. To carry out this mapping, the researchers analyzed a vast dataset collected by more than 20 magnetotelluric stations. These instruments record very subtle variations in the Earth's natural electric and magnetic fields, which are influenced by deep rock structures. Using advanced three-dimensional inversion techniques, they reconstructed a detailed image of the electrical resistivity of the crust tens of kilometers deep beneath the seabed. The model revealed a complex scenario. There are zones of low resistivity, indicating the presence of fluids such as water and therefore mechanically weaker, and areas of high resistivity, which are more rigid and locked. These differences in rock strength create critical boundaries where stress tends to concentrate. According to the authors, large magnitude earthquakes are likely to begin at these transitions between weaker and stronger sections of the fault, or at the edges of highly resistive zones. This discovery helps to clarify the mechanics of the fault and offers more precise tools to estimate where and with what force the next major event may occur. With more reliable information on the location and potential magnitude of future earthquakes, authorities will be better able to plan disaster prevention, preparedness, and mitigation measures, potentially saving lives and reducing damage in and around Istanbul when the inevitable happens.